In this video, as part of Bayesian learning, we will study a minimum description length principle. Minimum description length, shortly called as MDL principle, involves a way of trading off hypothesis complexity for the number of errors committed by the hypothesis. We are always interested to have less hypothesis complexity. The thing is, when you go for lesser complexity hypothesis, we may have to accept with more number of errors. When you have high complexity of hypothesis, we may have less number of errors. So it might select a shorter hypothesis that makes a few errors over a longer hypothesis that perfectly classifies or classifies to perfectly classifies or classifies to a nicely or classifies nicely, right, the training data. Viewed in this light, it provides one method for dealing with the issue of overfitting the data. One way of solving overfitting of the data using this MDL principle. I believe you know what is overfitting of the data. Overfitting of the data means, if you do not know, please understand this. When you give the training example to the hypothesis, it will classify the training examples perfectly. But when you give new examples, it may cause errors in classification. This is called overfitting the data. That is, we are overfitting with the training examples. So it's doing well with the examples, but it's causing errors with new instances. When you give new instances, we have H map is equal to argmax. H is an element of capital H, P of D by H into P of H. This expression is known to us. Now, since log is a monotonic function, this can be written in terms of logarithm. So you can write H map is equal to argmax. H is an element of capital H, log P of D by H to the base 2 plus log of P of H to the base 2. Now we have selected log 2 because we are comparing this concept with the information theory of communication engineering. In communication engineering, the shorter the codes, it is better. So here also we are trying to reduce the length of the hypothesis, right? In that particular way, we are interested in relating this concept with the communication theory. So H map is equal to arg min. Now this is arg max. Now I am changing this into negative. So I can write arg min. H is an element of capital H minus log P of D by H to the base 2 minus log P of H to the base 2. Now this log P of H to the base 2 is called as a description length of H when optimal representation is used. We will give a separate notation similar to coding scheme of communication engineering or information theory. LC capital H of H is equal to minus log P of H to the base 2. Now log P of D by H to the base 2 is the description length of capital D given H when again optimal representation is used. We shall write LC D by H of D by H is equal to minus log P of D by H to the base 2. Now that H map can be written as H map is equal to arg min. H is an element of capital H, LC capital H of H plus LC D by H of D by H. From this equation, we may say that short hypotheses are preferred, similarly to short codes in communication engineering. We may say that minimum description principle is finding hypothesis with the minimum description, where minimum description concept has already been discussed. And we can write HMDL is equal to arg min. H is an element of capital S, LCH of H plus LCD by H of D by H. As already told, MDL principle provides a way of trading of hypothesis complexity for the number of errors committed by the hypothesis. So it might select a shorter hypothesis that makes a few errors over a longer hypothesis that perfectly classifies the training data. I believe you understood this minimum description length principle concept. If you like this video, please give a like for this. Thank you.